let's look at some basics of polynomials and how to factor the greatest common factor from them. A polynomial is any expression that has one or more terms where you have a number in front and then x to a power that is a whole number. Alright, so some examples of polynomials would be like 6x squared minus 3x plus 1, or 5x to the 5th y plus 4xy plus 7 xy to the 5th. So you have a variable to a power. This would represent a polynomial expression. So let's look at this last polynomial here. This polynomial is made up of what we call different terms. So this would be a term of the polynomial, this is another term, and this is another term of the polynomial. The number in front of each term, the constant in front, is called the coefficient. Okay? 5 would be the power on x, and 1 would be the power on y here. The degree of the polynomial, or the degree of each term, is the total power of all the variables. So here we have x to the 5th, y to the 1st. The degree of this polynomial would then be the 6th power. Alright, so when we're factoring the GCF, or called greatest common factor, from a polynomial, we want to look at the highest number that divides exactly into all of the pieces of a polynomial. Here's my polynomial, 4x cubed plus 3x squared minus 6x. So I want to look at the number or numbers that go in evenly into each of them. And they all have a factor of x here. So what I'm going to do is I'm going to divide out an x from each term here. That x that I divide out goes in the front of my polynomial. And then since I'm dividing the x out, I would go 4x cubed divided by x would be 4x squared. So what we're doing is we're just dropping the power by 1. And then I'm going to divide out that 3x squared, so that would become 3x. And if I divide 6x by x, I have minus 6. So we factored out the common factor between all three of them. All three of the terms in my polynomial. Let's look at a little bit harder example of GCF, factoring the GCF out. Here we have 5x to the 5th y plus 10x to the 4th y squared plus 30x cubed y cubed. So I want to look at each individual component. We have the constants in front. We have our x values and our y values. Each term is combined together using multiplication. So that means that we can factor what we need to out. Let's look at the constants first then. So we have 5, 10, and 30. They all have a common factor of 5. So if I pull 5 out from each of these, I go 5 divided by 5 is 1, x to the 5th y. If I pull a 10 out here, or a 5 out of the 10, I have 2x to the 4th y squared. And then if I pull a 5 out of the 30, 30 divided by 5 is 6x cubed y cubed. Now there is more that I can actually factor out. I just wanted to show you what I'm doing step by step. So if we look here now at the x terms, here, here, and here, I have x to the 5th, x to the 4th, and x to the 3rd. So the highest amount of x's that can be pulled out is x to the third. It is the smallest one that they all have in common. So if I go x to the fifth and divide it by x to the third, I get x squared y. If I pull an x to the third out here, we get plus 2xy squared. And then if I pull an x to the third out here, that x to the third cancels all the way out. So I have 6y cubed. So I've pulled my greatest constant out I can, my greatest x variable out I can. Now let's pull the greatest y variable out we can. So we have y to the first, y to the second, and y to the third. The smallest y that we have in each of those is y to the first. So I'm going to factor x cubed y to the first out. And we'll have y to the first over y to the first cancels out, so we just have x squared. Y to the second factored out, or factoring out a y would just be y to the first. And then 6y cubed with the y factored out would be 6y squared. And that would be the factoring of that polynomial. The greatest factor total then was 5x cubed y to the first. Now normally you can do that all in one step, so let's take a look at an example where we would do that all at once. Alright, so in this polynomial we have 12x to the 6th y squared, 18x squared y to the 4th, minus 9x to the 5th y to the 3rd. Now we have the constants here. Let's look at those first. We have 12, 18, and 9. So 6 goes into 12 and 18, but it doesn't go into 9, so we've got to drop it a little lower. So 3. 3 goes into 12, 18, and 9. So 3 will be the greatest common factor of the constants. Now let's look at the x's. We have x to the 6th, x squared, x to the 5th. The smallest power on those is x squared, so that will be the greatest common factor. And then we have the y's. Y squared, y fourth, y third. So y squared is also the greatest common factor. Alright, so now we're going to pull out each one of those from each term. So 12 divided by 3 is 4. X to the 6th divided by x squared would be x to the 4th. Y squared divided by y squared cancels all the way out, so we don't have any more y's. Alright, so we're done with that term. Let's go on to the next term. 18 divided by 3 would be 6. X squared divided by x squared, the x's cancel out, so we have no more x's there. And then y to the 4th divided by y squared is y to the 2nd power. Now the last one is the 9x to the 5th y cubed, so I'm going to go minus 3. X to the 5th over x squared would be x to the 3rd, and then y cubed over y squared would be y. And we have our whole entire term, or whole entire polynomial factored.